So today we will study how to solve some optimization problems. So like the word you hear, you understand it, optimization is the way to look for an optimal or extreme value of quantity. Usually these problems are complex. There are two difficulties. You can find the the part of that comes from modelization, okay, of the problem of the real world problem, and also the function, the function you deal with, that can be that can with several variables, not only one, several variables. So those problems are very complex, and there is a domain, specialized domain in mathematics called optimization. Okay, where we developed tools, methods to solve different categories of problems. So today we will just limit ourselves to learn to solve two problems. Okay, so the first example, so here is example one. Is about a farmer who has a small field but rectangular field. Okay, a rectangular field where one side is by the river. Okay, so he has how many? He has 240 meters of fencing. So his purpose is to fence his field with that is a rectangular shape, and he wants what is the maximum area he can uh, with the maximum area he wants to fence. Okay, what more information we have? Okay, that's all. Okay, so we need mainly know what are the sides of this rectangle. So let's call it x and y. There's two sides. Okay, we want how can we choose x and y so that we use those 240 meters for a rectangle of fencing. Okay, so it seems so let's go, just we need to formulate the problem. Okay, so here we have two quantities. Fencing, that means I will cover a distance. Okay, so we need to have if we want to cover all the 40 meters, so that means we will have x plus y equal 240. Is it? Yes. And then the other information, we want the maximum area. Okay, so the area of the rectangle is x times y. Okay, and we want it to be maximum, to maximize. We want to maximize this quantity. So here you see this, now it's a new problem for you. So we will go slowly. An idea is to eliminate y, one of the variables. Let's eliminate y. So y will be 240 minus 2x, and then the area will be, I can express it only in x. It will be 240 minus 2x. Okay, which is 240x minus 2x2. And I see that I have a function of one variable. Okay, I need just to find the maximum of this function. Okay, because it represents my area. Yes, why not? So I can do with that. I can study quickly my function. It's polynomial, easy one. Critical points, okay, equals 0, gives me x equal 240 over 4, which is 60. Okay, and then once I have this, okay, 60, I can make a small table and study my variation. Like my function doesn't depend on the problem everywhere, so let's say 60. So my function here, derivative is positive if x is less than 60, positive negative here equals 0 here. So my function is increasing and decreasing. This is sine f prime, and this is the behavior of f. Here it's x. Okay, so yes, at 60 I have the maximum value over r. Here I am solving the problem maximum of f over r. It's f of 60. Okay, but if I am working just or even like that, we have an answer to the problem. Okay, okay, yes, okay. So my the area then, the area will be equal at f60. So the sides, yes, x will be 60 and y then will be 200, 240 minus 120, which is 120. So this is why how we can formulate the problem of optimization and solve it. Let's do another example. So this is the first example. Let's do another problem. Yes. What about, yes, example 2. Yes, example 2. Example 2, look how is the problem is set. Determine the point. So you are asked to determine, okay, determine the point on the parabola with equation, whose equation 2x2. No, parabola, not this one. It's this one. It's not parabola, usual parabola. Its equation is y2 equal to x. Okay, that is closest. That is closest to the point. Okay, the point 1, 4. Okay, so this is our problem. So let's try to see what is happening here. So a parabola like that, you can graph it. You can imagine yourself changing you can imagine that you are looking in this direction. Your parabola, you have x equal y2 over 2. So and you will graph it like that. Okay, as like y is the variable. Okay, so it passes through 0, 0, and when x equal 2, you will have y is y2 equal 4, so you will have 2, 2, so it passes by through 2, 2. So your parabola is like this one. Okay, okay, yes, and now yes, then where is the point 1, 4? Here is the point 1, 4. 1, 4 is here. Let's use the yellow one. 1, 4. So 2, let's say it's here. Here is the point 1, 4. So we are looking for a point. The problem finally reduces to look for a point on the parabola, so one point or more. that is closest to this point. Okay, maybe it's with this one or maybe another one. So let's closest. Now, the word problem is the difficulty in this kind of problems. So just interpret each word, what does it mean, and what tool, the suitable tool to use. Okay, to solve the problem. So we want the closest. So that means it is asking about the shortest distance. See, closest means then shorter distance to 1,4. Okay, now the point I'm looking is a point with, I can imagine it is points with coordinates xy. I don't know which one, and I can always measure this distance. Okay, we can always consider this distance. So this distance is distance. Okay, we can compute it. We have the coordinates of the 2 points. We know it's square root of x minus 1 square plus y minus 4 square, and we want to minimize this quantity, minimize. Okay, while what? The point xy remains on the parabola, while then 2x equal y2. Okay, so why not then include this information inside the equation, the distance. So I will have square root, okay, x minus 1 square plus or x, I will replace x. Yes, it's much easier than taking y square root and discussing the sign, etc. So let's avoid everything, and we will do also something else at the same time to save time. So instead of dealing this with this square root, I will prefer to take power 2 to this quantity, because it will help me to avoid deriving a square root function, etc. So I will consider, and I will always come back and take the distance. Okay, so the square root, so I will have x, we see that y2 over 2 minus 1 square plus y minus 4 square. Okay, so this is my f, I will call it an fy because it depends only on y. Okay, and then here finally I have something polynomial, which is good. Square. Okay, so next step now, we are dealing with a function of one variable. We know how to do it. Derivative, so 2 times y2 over 2 minus 1 times 2y over 2 plus 2 times y minus 4. Okay, and we need to solve this equation. So if you compute everything and simplify, you get exactly y3 minus 8, okay, which gives f prime y equals 0 if and only if the only possibility is y equal 2. Finally, the point we are looking for is this one, 2 at 2. That means this one is the shortest point, is 2, 2. The point 2, 2 is the solution to the problem. Okay, so how we can see it also, of course, you can use your table. Here is 2. The sign depends on y minus 2. It's positive here, negative here for f prime y. Equals 0 here, so decreasing, increasing, so it is the minimum point, okay, for f. Okay, this is the minimum point. We see it, we justify it by the table, for example, like that. Okay, so this is yes, to give you an idea how we deal with such problems. Okay, so the main part, the difficult part is more modelization. Okay, modelization of the problem. Yes, then of course still we are deriving then the step of the other steps of calculations. Okay, Thank you.